Good, whatever time it is you are watching this. Welcome to my house where I spend approximately half my life. As much as our horses and donkeys would love to be a part of this, for this representation we are going to be using these lovely ladies featuring a single dude.
So, Gibbs Free Energy. What the heck is that, you might ask? Good question. Gibbs Free Energy is defined as a thermodynamic quantity equal to the enthalpy minus the product of the entropy and the absolute temperature. Basically, it tells us whether or not the equation is thermodynamically favorable or likely to occur on its own. This doesn't mean that it's actually going to occur because high activation energies, blah, blah, blah. We'll talk about that some other time. Which, all that sounds complicated, but it's really not. And there are three main equations we can use to find Gibbs Free Energy. And with some help from our avian friends, we're going to teach you exactly what the heck to do with Gibbs Free Energy.
First, we need to remember what the favorable conditions are. So we want a negative delta G value, a negative delta H value, and a positive delta S value. You learned we need those values for a favorable reaction. You learned in Unit 6 that a negative delta H or enthalpy value is exothermic, and a positive one is endothermic. Or uses heat. So for this, we're going to want exothermic conditions.
In this presentation, a favorable delta G correlates to the successful gathering of one egg. A negative or favorable enthalpy value will be represented by this heat lamp. Chickens lay more eggs when they are kept at warmer temperatures.
T represents the temperature the reaction occurs in, which is always Kelvin. For this representation, that will simply be the temperature outside right now. A breezy 70 degrees Fahrenheit, which would be what in Kelvin?
I don't know. You add 273.5 to it.
1.5.
Wait.
Yeah, anyways. So delta S, the change in entropy, is the measure of disorder or chaos of a system. A positive delta S indicates that the system has a greater disorder, as seen in an equation like H2O solid forms O2 gas and 2H2 gas, where there are more moles of gas than solid as the reaction progresses. A negative delta S indicates that the system has less disorder or less moles of gas. So that would be like if the reaction that I just said went in reverse. Since we want a positive delta S, we want to have a greater measure of randomness, and we are going to use the movements of chickens to do so. A calm chicken means there's less chaos, but like a frenzy of chickens means that there's a lot of chaos and a positive delta S. Can I do it?
For the next equation, the idea is much the same. We still want a negative delta G value or a thermodynamically favorable reaction. And this will still be represented by eggs. But what if we aren't given delta S or delta H? This is where we can use the equation delta G equals negative N F E cell or electrochemistry.
You have learned about anodes, cathodes, and voltage in electrochemistry, but what does this have to do with this equation? Negative N is the number of moles of electrons, or E-. F is Faraday's constant, which is 96,485 coulombs per mole, and E cell is the voltage or standard reduction potential. In this situation, N is the number of chickens, F is a constant, and E cell is the different breed of chicken because different reactions will have different values.
Quick!
Lavender orpington, and it lays more eggs than it runs the cinnamon queen.
Almost fails. There is still one last option. Delta G equals negative RT ln K. At this point, you should be pretty aware of what each of these values mean. R is the gas constant, T is still the temperature, and for our purpose, and K is the equilibrium value. For our purposes, the K value, so the products of reactants, will be chickens over scoops of feed. The more chickens that can be fed with less feed, the greater the K and the greater thermodynamic favorability. However, we can't skimp out on feed too much, because as previously, well, probably pretty obvious, emaciated chickens don't produce a lot of eggs, so we need to keep our chickens fat and happy.
not mean it will occur or it may occur really slowly. Sometimes a catalyst or another reaction is also needed to help with the activation energy so that a reaction can occur.
This is why you add a rooster, and we will not be going into that. Guys, we just did chick chemistry!
Yeah!